All right, guys, so before we get started today, are there any questions on any of the assignments thus far? Any question over any of the homework assignments?
It's a whole 5.5 because I was up here.
What we're looking at today are inverses. The inverse of a function f is also a function, if and only if no horizontal line intersects the graph in more than one point. So if we can draw a horizontal line and it intersects the graph in more than one point, then it does not have an inverse. Or more importantly, the inverse is not a function. The inverse is not a function. It can still have an inverse, but the inverse is not a function. Now for those, like this here, where it crosses in more than one place, we can still have an inverse for it, and it'd be a function, except what we have to do is the original function, we have to apply a restriction to it. Essentially, we have to remove this half of the graph, and then we can say it does have a inverse because it doesn't cross in more than one place. We essentially apply a restriction to it. But, so an inverse, and what we're doing with an inverse is we're switching the domain and range. The domain and range values. We're flipping it to find its inverse. And an inverse and a function really are mirror images of each other. And the mirror image is going to be across the line y equals x. So if we graphed a function and its inverse, it will flip across the line y equals x. And the domain and range of the function is the inverse of its inverse. So whatever the domain is for our original function is the range of the inverse. And same with the range and domain. They flip. So what we're going to do with these here, first few problems here, is we're going to find the inverse. We're going to go through the steps of finding the inverse. And then we want to find the input value when the output is -7. Because the input values of the inverse are the output values of the original function, because we're flipping the domain and range. Now, with finding the inverse, the first main step is to change f of x to y. We can say rewrite, we can say change. Either way, it's going to be the same thing. So our first step is to change f of x to y. That's our first main step. Now, if the function already has y equals, we don't have to do this. However, for this function here, we have f of x equals 2x plus 3. So the first thing I'm going to do is change f of x to y. And as I've said a few times now, the domain and range flip. The domain of our function becomes the range of its inverse. The range of our function becomes the domain of its inverse. The domain and range switch. Our domain, as we think of it, are the input values, the x values. The range is the y. So if we're finding the inverse, we're switching the domain and range. So what we're going to do is switch x and y. We're going to switch x and y. So with this here, instead of y equals, it's now x equals 2y plus 3. We switch x and y. We don't do anything else. We just flip the two. Any questions on steps 1 and 2?
Why do we switch x and y?
Because for the inverse is we flip the domain and range.
Yeah.
So our original function f of x, domain and range, or, well, let me explain it this way here. Because we have a domain and range. And for any point in the domain, it is mapped or it goes to a specific y value. If we plug x into, we'll call this f of x. So if we plug 4 into f of x, we get a value out, say 6. So we plug 4 in, we get 6. If we plug 5 in, we get 12. We plug a value into the domain at x value, we get a range out. The inverse, f inverse of x, is taking this range value and putting it back to the domain. So 12 to 5 or 6 to 4. And what we're doing is we're flipping the domain and range. Our x value and y. As for f of x, we're taking x to y. For the inverse, we're taking y to x. And to really state that for any function, to see what it is, we flip the domain and range. We switch them. Does that kind of make sense? Are we good up to this point here? Yes? Third step. Solve for y. We want to get y by itself. Well, looking at this here, the first step in getting y by itself is to, well, subtract 3 from both sides, telling us that 2y is equal to x minus 3. Then what do we do next? Then we divide by 2, telling us y is equal to x minus 3 divided by 2. Any questions on any of this here? And lastly, we're going to change y to f inverse of x. And the -1 next to our f is signifying that this is the inverse of the function f of x. So f inverse of x is taking all the range values of f of x and taking them back to the domain. Taking our output values back to our input values. Questions on this here? Now we'll do this here. So it asks find the input value when the output is -7. Well, if we plug it into the inverse, because the inverse is taking the range back to the domain, the output value back to its input, we'll find out what it is. So we can say -7 minus 3 divided by 2. Well, -7 minus 3 is -10. And -10 divided by 2 is -5. So f inverse of -7 is -5. What that also means is that if I plug -5 into our original function, we would get -7. And I could do that in a calculator here. We can say 2 times -5 plus 3 is -7. Questions on any of this here? So it's just telling us that f of x is taking -5 as an input to the output value of -7. The inverse is taking -7 back to -5. Questions on any of this here? F of x equals 3x minus 5. Well, the first thing we need to do is change f of x to y, because that's the first step. Now the second step is to switch x and y. So we have x is equal to 3y minus 5. Now we just need to solve for y. We need to get y by itself. And the first step in getting y by itself is to add 5 to both sides, which tells us that 3y is equal to x plus 5. And last but not least, we need to divide both sides by 3, telling us y is equal to x plus 5 over 3. Any questions on how we got y by itself? So that gets us through steps 3. Step number 4 is to replace y with f inverse of x, giving us the inverse function. Now, will we always use f inverse of x? Well, no. Because if the starting function was, say, g of x, we would use g inverse of x. We would replace the f with g. Or if we started with h of x, we'd have h inverse of x. We're just using f here because that's what it started with. Any questions on this here? Now, we'll do it the last time with this here, finding the output. So really, finding the input when the output is negative 11, using just the inverse, plugging it in, saying that we have negative 11 plus 5 over 3. And again, at this point here, we can type the whole thing into the calculator. We can tell the calculator negative 11 plus 5 over 3. But if we did this by hand, and negative 11 plus 5 is negative 6. Negative 6 divided by 3 is negative 2. So f inverse of 11, negative 11 is negative 2. Telling us if we plug negative 2 into our original function, we would get an output value of negative 11. Questions on any of this here? We feel pretty good with finding inverse. We're ready for the next one. Find the inverse of this here. We're not going to worry so much about the output. We're just going to find the inverse. So we're told f of x is equal to x minus 2. So the first thing we need to do is replace f of x with y. Y is equal to x minus 2. Our next step is to switch x and y, telling us x is equal to y minus 2. Then our third step is to solve for y, or get y by itself. And we can do that by adding 2 to both sides. These will cancel, telling us y is equal to x plus 2 is y by itself. Yeah. So we can replace y with f inverse of x is equal to x plus 2. Now, if the starting function didn't give us f of x, it just started out as y equals x minus 2, we don't have to do the f inverse part because we don't have a function to say it's the inverse of. As f of x and f inverse of x are just ways to name the functions so that we can distinguish between the two, which one we're talking about. I'm not going to worry about the inputs for this here. Questions on finding the inverse? We good with these here? Okay, this one here is a little bit different because we had 2 equals x squared, yes? All the ones up to this point have been in a line. Now, if we look at the graph, we'll clear both of these out. 2x squared, graph. Can we draw a horizontal line that crosses the graph more than once? Let's say 3. Does it cross the graph more than once?
Oh, yeah.
Yeah. So does this, by definition, have an inverse? Yeah. Inverse is not a function. So it technically does have an inverse, but its inverse is not a function, and we'll see that here in a minute. Now we can still find an inverse because we take the function, and first step is to replace f of x with y. It's equal to x squared. Our next step's still the same. We switch x and y, telling us x is equal to 2y squared. And our third step is to solve for y, get y by itself. So what's the first thing we can do? Almost. Because we will need to take the square root eventually to get the square to go away. We need to divide by 2. And whenever we're trying to get a variable by itself or solving for a variable, always go in kind of what I think are simplest operations to complex. So the most simplest operations that we have are addition and subtraction. If there's a way that we can add or subtract a number off either side to get the variable by itself, I start there. The next step up, kind of next more complicated, is multiplication, division. And then the most complicated out of all of them are our powers and roots. So once we do each one, we kind of go back through the checklist and see. So addition, subtraction is still gone. Multiplication, division has been simplified. Now we're just left with radicals. Because if I take... So since these two are being multiplied, division, 2 divided by 2 is... So then we just have x over 2. Yes, and we can do that by square rooting both sides. These two will cancel, giving us y by itself. However, whenever we take the square root of both sides, we have to add a plus or minus. Because whenever we take the square root of both sides, we add a plus or minus. If we square both sides, we do not. If we square root, we take an even root of both sides, we add the plus or minus. So that's telling us that f inverse of x is equal to plus or minus the square root of x over 2. Now with this chapter on inverses, I will take this as the final answer. I'm not going to make you rationalize this here, because part of our radicals chapter says we can't leave a fraction inside of a radical, but purely for the inverses, I will let you put this here as your answer. Questions on this here? Now we said an inverse, a function, if it is a function, has to pass the horizontal line test, or not horizontal, vertical line test. We can't draw a vertical line and it cross more than one place, yes? Well, with this here, second square root, alpha y equals inner, x over 2, is one of the ones we have. We do have the positive square root of x over 2, but we also have the negative square root of x over 2. We have the plus and minus. Now for this here, so that we can see it. Yes, I can change the colors on this one here. So that there is its inverse. We flip the domain and range. And these mirror, and will always mirror across the line, y equals x. So it's just flipping it across that. So it is, the red graph is its inverse, but as we can see, if we drew a vertical line, it would cross it at more than one place, so it's not a function. But its inverse still exists. Any questions on this here? Are you ready for the next one? This one here, we have a cubic. But the process doesn't change. The first thing we can do is replace f of x with y. Y is equal to negative x cubed plus 3. So that takes care of steps 1. Now step 2, we switch x and y. So it'll tell us y x is equal to negative y cubed plus 3. And now that we have it in this form, we need to get y by itself. We need to solve this for y. And the first step in solving this for y would be to what? Subtract 3. So it's good to do addition or subtraction first, because 3 minus 3 is 0, telling us negative y cubed is equal to x minus 3. What can we do next? So multiplication, yeah, we need to get rid of the negative. And we can do that by one of two ways. We can either divide everything by negative 1, or we can multiply everything by negative 1. And it doesn't matter which. So if we choose to divide everything by negative 1, we can, which will tell us that y cubed is negative y cubed divided by negative 1. Negative and negative makes a positive, and we get y cubed equals x divided by negative 1 is negative x. Negative 3 divided by negative 1 is plus 3. And what do we do next? We need to get rid of the exponent, yes? How can we get rid of the the cubic? With the cubed root. The third root is the cubed root, and the third power will simplify, leaving us y by itself, is equal to the cubed root of negative x plus 3. Now, because we have an odd root and not an even root, we do not need the plus or minus. It is only included on even roots. If the index, the number inside our little v, is an even number, we add the plus or minus. Here, we don't need it. And that's it. We're not going to worry so much about the finding the input when the output is a 2. Any questions on finding inverses? Let's look at the next one here. I think we're starting to get the hang of this, yes? I mean, it's not, there's only one other thing we're going to add to it. Here, f of x equals 1/3 x minus 2. First step, replace f of x with y. Then our next step is to switch x and y. What's our next step? Add 2. That'll tell us 1/3 y is equal to x plus 2. What is our next step? Yes, we can divide by 1/3. Now, we'll do that. There is an easier way. Because if we divide this by 1/3, we also have to divide the other side by 1/3. 1/3 divided by 1/3 is 1, is equal to, well, I'm fine with radicals, fractions inside of radicals, but we can't have a fraction inside of a fraction. We're going to have to simplify it. Now, what this other side is telling us is that we have x plus 2 divided by 1/3, yes? But to divide fractions, the way that we go about this is apparently rewriting over the one before it, is keeping the first one the same, changing the division to multiplication, and flipping the second. And we can multiply this here, telling us y is equal to 3x plus 6. Or that f inverse of x is 3x plus 6. Or we could have multiplied by 3. Questions on this here? Because the other route, instead of dividing by 1/3, is we could have multiplied by 3, and it would have simplified it a little bit quicker. Any questions on any of this here? Any questions over anything we've done so far? Find the inverse of f of x equals x squared, comma, x is greater than 0. Now, the x is greater than 0 is restricting it so that the function that we have is just this here. And since it only goes to from the origin to the right, it only crosses, the horizontal line could only cross at one point. Therefore, its inverse is a function. However, what we do doesn't change. We still switch f of x with y. Y equals x squared. At this point here, we switch x and y, telling us x is equal to y squared. At this point here, we would, well, y squared, there's nothing added to it. There's nothing being multiplied by it. So the only thing we can do is take the square root of both sides, telling us y is equal to square root of x. Now we can put the plus or minus. Now looking at the graph we drew, or I drew here, the x values are all positive, yes? X is greater than 0. The y values are also all positive. So the domain of the original function is x is greater than or equal to 0. The range, the y values, start at 0 and go up. So they are also greater than or equal to 0, yes? So for this function here, the domain and range, the values that go into the function, and the values that come out of the function are all positive, yes? So the inverse values have to all be positive as well, which means, actually I don't need that. It's just going to be the square root of x. Yes. So f inverse of x is just going to be the square root of x. And for all the ones on the homework, when we do have that x is greater than or equal to 0, we can just say square root of x. I'm not necessarily going to count, if you do put the plus or minus, I'm not going to count off for it because that is part of the steps. I'm not going to go that far with it. Okay? Any questions on this here? Any questions over anything we've done so far? Are we ready for the next one? Find the inverse of f of x equals x squared minus 2. So again, we're going to go through the exact same steps. So we're going to say y is equal to x squared minus 2. The next thing we're going to do is switch x and y. Say that x is equal to y squared minus 2. Then our next step would be to what? We would add 2 to both sides to get y squared by itself. And adding 2 to both sides will tell us that y squared is equal to x plus 2. Then we would square root both sides, telling us y is equal to plus or minus the square root of x plus 2. Now, since x in the original function was greater than 0, the y values are also going to be greater than 0. So we wouldn't need the plus or minus. We would just have the square root. Now, if you do include the plus or minus in your answers, I will not count it wrong. Questions on this here? Yes, sir. Let's look at the next one. So, we're going to look at this one here, this cubic. Determine whether the inverse of f is a function. If, especially we're wanting to really see if these are inverses. Clear that. Okay. Clear. We can say, well, 2x cubed plus 1. 2x to the third plus 1. I would graph it. And as we can see here, it does look like as we get close to 0, x equals 0, we could draw a straight line, but it's just very small. This actually does have an inverse, and its inverse is a function. So, our steps for finding the inverse are still going to be the same. We switch f of x and y. F of x we rewrite as y. Then we switch x and y, telling us x is equal to 2y cubed plus 1. And after we do that, we solve it for y. And the first step in solving for y is 2 minus 1 from both sides, telling us that 2y cubed is equal to x minus 1. Then the next thing we can do is what? Divide both sides by 2, telling us that y cubed is equal to x minus 1 over, and last but not least, we take the cubed root of both sides, telling us that y is equal to the cubed root of x minus 1 over 2. So we do have y by itself, which tells me that f inverse of x is equal to the cubed root of x minus 1 over 2. How do we feel about inverses? Yeah, they're not bad. I think we do one more, and then we'll move on, because the only one that we haven't done, I think we feel good with cube roots. We're at cubics. Let's look at this one here, because we haven't looked at one that is a square root as the starting function. We've dealt with some that had a square root as our inverse, but not as our f of x. But this here, again, just like our other functions, is going to work the exact same. It's going to work the exact same. So the first thing I can do is replace f of x with y. Okay, that's done. Step 2, switch x and y, telling us x is equal to 2 times the square root of y minus 3. That takes care of steps 1 and 2. Step 3, solve for y. We want to get y by itself. Well, there's a few things that we're going to have to do. Because there's nothing being added or subtracted to the radical, but we do have the multiplication of 2, yes? So the first thing we can do is divide both sides by 2. Telling us that the square root of y minus 3 is equal to x over 2. Now we do have that minus 3, and it's very tempting to want to add 3, but the square root is keeping the y minus 3 together. It's really holding it all together, so I can't just add 3. So we divide the 2 first. Now before we can get at the minus 3, we have to take care of the radical. And to fix the radical, we have to, what? Square. Because the square root of something being squared cancels out. Just like squaring a square root will cause those to cancel, leaving us with y minus 3. Now whenever we square both sides, we don't add the plus or minus, but we can square x divided by 2. Because the numerator is going to become x squared. We apply that power to the top and bottom. So x squared is x squared. The denominator 2 squared is 4. And now we can add 3. Almost. Telling us y is equal to x squared over 4 plus 3, or we don't have to make that into a single rational expression. We can leave it as x squared over 4 plus 3. Any questions over any of this here? We good with all this here so far? Yes? How do we feel about radicals? You feel good with these here? They're not any more difficult than our other functions. We just have to square them first. Now that brings us to the last piece here. Verify that these two functions are inverses. Now the way that we verify two functions are inverses are our composite functions. F of g of x. F of g of x. If f of g of x is equal to g of f of x, and they are both equal to x, then they are inverses. So two functions are inverses if f of g of x is equal to g of f of x, and they are both equal to x. If they give us something other than x, they're not inverses. So it doesn't matter if they're both give us a value of 14x, they are not inverses. It has to equal x. And so we did these here on Friday. So the first thing is we work from the inside out. So we plug x into g of x, or really we replace g of x with its function, x plus 1 over 3. So we're working with f of g of x. I should have written that out first. And at this point here, we're going to plug this into every x in f of x. So I'm going to replace, so 3 times x, well, we're replacing the x with x plus 1 over 3. Any questions on this so far? Well, when we multiply x plus 1 over 3 by 3, the 3 and 3 will cancel, telling us that we have x plus 1 minus 1, which is x. So f of g of x does equal x, yes? Now we can do the other one, g of f of x. So really I should have started off with f of g of x for the first one here. So g of f of x, well, we can replace f of x with its function, which is 3x minus 1. And just like with the one before, in every place that x appears in g of x, we're replacing it with 3x minus 1. We have 3x minus 1 plus 1 over 3. Now we can drop the parentheses, telling us that we have 3x minus 1 plus 1 over 3. Well, the negative 1 plus 1 gives us 3x over 3, and that simplifies to x. So these two are inverses because our f of g of x was equal to x. Our f of g of x was equal to x. And since they both gave us x, they are indeed inverses. Any questions over this here? Unfortunately, we'll need to stop here. We'll finish this up tomorrow, and then the rest of the hour will be time for y'all to do homework.